How are we doing, guys? This is just carrying on exercise 11 C. I want to have a look at questions 10 and questions 12. This is on page 200, 201. So question 10, first of all, says a hollow right angular cone of semi-vertical angle alpha, that's this angle here, where tan alpha is 3 over 4, is fixed with its axis vertical and vertex downwards, as in the diagram. The inner surface of the cone is rough with coefficient of friction 1/2, and the cone rotates about its axis with uniform velocity of 7 radians per second. A particle of mass m is placed on the inside surface and rotates with the cone at a vertical height h above the surface. Okay, so there's some height h. Above the vertex. Calculate the normal reaction of the particle with the inside surface and height h above the vertex if the particle is about to slide down or if the particle is about to slide up. So there's two parts to this question, so we'll look at about to slide down first. Our particle is here. Now the forces acting on it, well, there's going to be weight, and it has mass m, so that's mg. There's going to be a normal force perpendicular to the surface, so I'm going to call that n. And I'm going to have to resolve that, so it's important to note if that's alpha, that's 90 minus alpha, that's where alpha crops up again. And there is also the frictional force. Now if it's about to slide down, as in part 1, then the frictional force is opposing that motion, so it's acting upwards, and that's a half n. It is our coefficient of friction times our normal force. We've also got that height h that they've asked about in the question, and of course you've got your radius of motion because this thing is moving in a circle, so you've got some radius r there. So let's have a look. Start off by saying alpha, we're told, has components, tan alpha is 3 over 4, which means this up here is 3 squared plus 4 squared is 5. That's our 3, 4, 5 triangle, so we can say sine alpha is 3 over 5, cos alpha is 4 over 5. Now, if we look at our forces, we're going to look at up and inward, so we need to resolve both the normal force and we'll need to resolve our frictional force. So let's start off with the normal. Okay, that is a force acting in this direction, angle alpha, so the inward component is going to be, if that's n, this will be n cos alpha. The upward component will be n sine alpha. If we look at our frictional force, that's acting in this direction. Okay, so the upward component, well, if that's a half n, now sorry, if you look back in our diagram, alpha in this triangle will crop up at the top. Okay, I suppose the best way to look at that is if you think of that as one line there, and we've looked at two parallel lines within it. So alpha has cropped up here, so it'll crop up up here as well. Okay, so that's alternate angles, that junior set theorem. So alpha is here, which means this is a half n cos alpha on the adjacent side, and on the opposite side it's a half n sine alpha. Okay, so let's set up our equations of motion. Forces up equal forces down. And by the way, the only difference between part 1 and part 2 is the direction that frictional force is going to act in. So in this one, forces up equal forces down tells us, well, the upward forces from the normal are n sine alpha, and from the frictional force we've got a half n cos alpha, and that equals the weight, mg. And we know sine alpha is 3 over 5 and cos alpha is 4 over 5, so that becomes 3n over 5 plus a half of cos alpha is 2 over 5, so 2n over 5 equals mg. And that gives us 5n over 5, or n equals mg. Okay, for our inward forces, cause our centripetal force. So our inward forces here, well, we've got an inward force in the normal of n cos alpha, and we've got an outward force in the frictional force. Okay, that's acting in this direction here. That'll be minus half n sine alpha, and that's equal to m, the mass of our particle. The thing is rotating at 7 radians per second, so that's 7 squared times our radius. Okay, so n we know is mg. Cos alpha is 4 over 5 minus a half of mg. Sine alpha is 3 over 5 equals 49 mr. Okay, so first of all, m is a common factor to every term there, so we can divide through, and we get 4g over 5, which is the same as 8g over 10. I'm just doing that because I'm going to get a 10 here in a second, minus 3g over 10 equals 49r. Subtract them, that's 5g over 10, which is g over 2, equals 49r. G equals 98r, and r then is 9.8 divided by 98, 0.1. Now we've been asked to find the height, so if we know that's 0.1 and they're related by tan, so if we're being asked to find the height, we can say that, here's our radius is 0.1, the height is what we want, h, and there's alpha. We'll have tan alpha is 0.1 over h, and we're also told it's 3 over 4, so solving that we get 0.4 is equal to 3h. H is 0.4 over 3, which is 4 over 30 meters. Oh, sorry, 2 over 15 meters is our height. Now, what else have they been asked? Calculate the normal reaction of the particle. Okay, and we've done that here in the first part. For part 2, it's almost the same diagram, okay, except our normal reaction is acting downwards. So this frictional force here is going to be just in that direction with an inward component of a half n sine alpha and a downward component of a half n cos alpha. So I'm not going to sketch a new diagram. I'm going to say forces up equal forces down. As we come back to our original diagram here, we still have the upward component of our normal force, so that's n sine alpha minus a half n cos alpha. This is now a downward force. Okay, so as the thing is about to slide out, friction is acting against that direction. So friction is a downward force, and that component of it is downward. So that's minus a half n cos alpha equals mg. Okay, there's our forces up equal forces down. Again, we know sine alpha and cos alpha, so we can find n fast enough by saying n times 3 over 5 minus a half of cos alpha again is n times 2 over 5 equals mg. Okay, and that gives us n over 5 is mg, and in this circumstance our normal reaction is 5 mg. Okay, second part that we always go to is that our inward forces are causing the centripetal force, causing this thing to move in a circle. So our inward force here is our previous n cos alpha. Okay, this inward force here. And now, because friction is acting downwards, we have an inward force from friction as well. So plus a half n sine alpha. And that equals m 7 squared r. Okay, so m omega squared r is our formula again. N we know is 5 mg. Cos alpha we have from earlier is 4 over 5. Plus a half of 5 mg. Sine alpha is 3 over 5. Equals 49 m r. So 5's cancelled there, we're left with 4 mg. 5's cancelled there, and 2 goes into 3 1.5 times, so plus 1.5 mg equals 49 mr again. Common factor of m in each term, 4g plus 1.5g is 5.5g equals 49 r, and r is going to be 5.5 g over 49. So go to the calculator, work that out. Excuse me. 5.5 times 9.8 divided by 49. We're getting a radius of 1.1 meter, which means our height, to come back to what we did up here, we now have 1.1 height and alpha. Okay, and we know that tan alpha is 1.1 over h, and that's the same as 3 over 4. So we get 4.4 is 3h. H equals 4.4 over 3, which is, what's that, 1, oh, it's a bit of a mess. We'll say 44 over 30, or 22 over 15. We'll leave it in fraction form. Okay, so 1 7/15 of a meter. So the other question I want to look at in this example is question 12. Okay, so a particle of mass 1 kilogram is attached to 2 strings. Here it is here, particle of mass 1 kilogram. One string is attached to a point P on a smooth vertical wire. The other end of the second string is tied to a ring of mass 3 kilograms, through which the wire is threaded, so that the wire is vertically below P. The particle and strings turn in a horizontal circle about the wire with constant angular speed 14 radians per second. Find the tension in each string and the angle which the strings make with the vertical correct to the nearest degree. So here's our wire, point P, particle of mass 1 kg attached to a ring of mass 3 kg. So if we look at the forces, we've got a weight here of g, we've got a weight here of 3g, we've got 2 separate strings. This is not the same string, so the tension in them is going to be different. Call this one T1, and I'm going to call this one T2. You'll need to recognize for this the tension acts in both directions. Okay, if somebody pulls a rope here, well, this person feels like they're getting pulled in the opposite direction, and if the person up here is pulling the rope, they feel like they're also getting pulled in the opposite direction. So tension acts in both directions. We're also told that that's a 1 meter length, and that this is a 1 meter length. And we can see that that's a common side. Okay, so we've got 2 common sides in this, and we are also told, we can also see that we've got 2 common sides and a right angle in both triangles. So these are congruent triangles. So I can say that's the angle there, alpha, that we're looking for, which is the angle made with the vertical, but that's going to be the same as this angle up here, the angle that the higher up string makes with the vertical. So our tension forces need to be resolved. So let's look at T1 from the perspective of this 1 kilogram particle. T1 is pulling upwards, and it has an inward component of, if that's alpha, then it's the opposite side of our triangle, so that's going to be T sine alpha, and it has an upward component of T cos alpha. This tension here, from the perspective of the 1 kilogram force, it's pulling downwards. So from this guy's perspective, T2, this should all be T1. There's alpha, so this is going to be T2 sine alpha inwards, T2 cos alpha downwards. Now that same tension from the point of view of the 3 kilogram mass is an upward tension. It's going to act that way. Okay, so it's going to experience the same size force, T2 sine alpha inwards, but the T2 cos alpha, it experiences as an upward force. So from the 1 kg point of view, this guy, our forces up equal forces down equation is going to say our upward forces are T1 cos alpha, and that equals our downward force mg plus the downward tension from this second string, which is T2 cos alpha. Our forces in are the centripetal forces equation is going to say T1 sine alpha is an inward force plus T2 sine alpha is an inward force, and that's going to equal centripetal force, so that's a 1 kilogram mass, so m omega squared r is going to give us 1. Omega in this question is 14 radians per second, and r we don't know, it's that distance there. Now I'm going to actually just look at that triangle as well. R, we know that this is 1 and this is alpha. Okay, so if I want to find the length, the radius of the rotation, which is going to be useful to me, well, hopefully I can say that's my opposite, that's my hypotenuse. So I can say sine alpha is r over 1. Okay, so my r is equal to sine alpha. So that is going to say 196 sine alpha. So T1 sine alpha plus T2 sine alpha is 196 sine alpha. Well, sine alpha is common. So T1 plus T2 equals 196. From our 3 kilogram point of view, sorry, I'll need that at some stage too. From a 3 kilogram point of view, we get that the upward force, which is T2 cos alpha, equals the downward force, which is 3g, the weight. Okay, and we can use that over here. 3. Now, where that says mg, I apologize, that mass is 1. So that should say 1g. Okay, so we're trying to find the tension, so I'm going to see if I can get rid of cos alpha here, and I'm going to say cos alpha is 3g over T2. Okay, and I'm going to plug that into this equation here. So this now says T1, instead of cos alpha, I've got 3g over T2, equals g plus T2 times 3g over T2. So that's nice, they cancel. G plus 3g is 4g. So I get T1 times 3g over T2 equals 4g. Okay, g's cancel. Bringing the t across, I get T1, 3t1 equals 4t2, or T1 equals 4t2 over 3. So plugging that back in over here, 4t2 over 3 plus t2 equals 196. Okay, so that says 4/3 plus 3/3 is 7/3 of t2 is 196. Sorry, I'm running out of space here now. On the page. 7/3 of T2 is 196. 7T2 is 196 multiplied by 3. T2 is 196 multiplied by 3 divided by 7. Which if I go to my calculator, 196 multiplied by 3 divided by 7 equals 84 newtons. Come back up here to get T1 plus 84 newtons equals 196. From here means T1 will be 196 minus 84. 196 minus 84 is 112 newtons. So they've asked us to find the tension in each string and the angle which the string makes with the vertical. So we need to go back and find alpha. So let's use this here. Okay, I know that T1 is 112 and T2 is 84. And finally I know that cos alpha is 3g over T2, which is over 84 newtons now from this equation here. So that is going to be 3 times 9.8 divided by 84, 3 times 9.8 divided by 84, and we're getting ourselves 0.35. So alpha is the cos inverse 0.35. Inverse cos of 0.35 is 69.51 degrees. And I think we're okay. Correct to the nearest degree is 70 degrees, and that's the question. Okay, I'd suggest you try question 11 yourselves. I'll see you next time.